Comes to this question, they are saying that three processes are arriving at time 0 with execution times of 10, 20 and 30 units respectively. So what does that mean? They are giving this information. So they are saying that P1, P2 and P3 are available and their arrival times are 0, 0 and 0, right? And their burst times, which means execution times, are 10, 20 and 30. And again they are saying that each process spends first 20% of execution time doing IO, which means this execution time is again divided into three parts. First 20% executing IO and doing IO, and then 70% doing computation, which means at CPU, and then the last 10% again doing the IO. So again this execution time is three parts. One part is IO and then computation and again IO, right? Then compute the percentage of idle time for shortest remaining time first. If this is the case, then they are asking us to find out the idle time, the CPU idle time for consider the percentage of CPU idle time. It is CPU idle time for shortest remaining time first. So it is shortest remaining time first. First write down the burst time. It is saying that they have three types. One is IO and then the CPU and then IO. This is the total execution time, right? And the first one is saying that it requires 10 units of time. First one is saying that P1 requires 10 units of time, and out of which 20% is doing IO, which means 2 units is IO, and then 70% is CPU, which means 7, and then 10% is IO, which means 1. And similarly, second one, which is having 20 units of execution time, is going to spend 20% of IO, which means 4, and then 70% doing execution CPU, which means 14, and then again 20%, 10% doing IO, which means 2. And the last one is 30 units is again split up this way: 20% IO, which means 6, and again 70% CPU, which means 21, and again 10% IO, which means 3. Got it? So this is what they have given us. So initially this is IO and then CPU and then this, right? So now we are going to use shortest remaining job first. So initially, if I start at 0, there is no process to execute. Even though all the processes are arriving at time 0, all of them wants to perform the IO first. So all of them are going to go to IO for some time, right? Therefore, what happens is, for 2 units, no process is available. So CPU is idle from 0 to 2. And then process P1 becomes available. Therefore, P1 becomes available here, and I can run it till completion. The reason is, this is the smallest job and all the jobs are available. Therefore, there is no further job which will be smaller than this. So you can run it till completion. So I can run it till completion till 9, right? By time 9, right, both P2 and P3 will be available. But then what should I run? I should run P2. Therefore, I am going to run, because P2 is the shorter one. Therefore, I am going to run P2 for how long? 4 units, which means till 13 I am going to run it. And then P2 is at this point, P2 will go for IO. So till how long will it go for IO? So if it is starting at 13 to go for IO and it requires 14 units of IO, therefore it is going till 27. Till 27 units, this P2 will go for IO, isn't it? Right? And now in the meanwhile, you cannot keep the CPU idle. Anyway, P3 is available. So let's schedule P3. Now if I schedule P3 will run for 21 units of time. Oh, this is not 1 second. There is a small mistake here. See this? Now, in this case, P2 got scheduled at 9. By the time it finished its IO, right? Therefore, it could run for 14 units. 14 units is the CPU time. So from 9 till 14, it will run till completion. So 9 plus 14 is how much? 23. So till 23 units it will run, isn't it? Fine. Now P2 is also over, and then it will go for IO. IO will take for 2 units, no problem. And next I have to schedule P3. Now P3 will run for initially 21 units. So what is 23 plus 21? It is, I think, 40. 23 plus 21 is 44, right? So till 44 this P3 is going to run, right? And then it will go for IO for 3, which means till 45 it is going to go for IO. So this is idle and this is idle. CPU is going to be idle during these two times, and next schedule can start. And it is a dilemma whether to take this part as idle or not, because it can start with the next one, right? So you need not take this one as the idle part. The reason is simple. So once P3 is done with its execution, CPU is again free, and CPU could be scheduled for other process, right? Therefore idle time is only 2. So out of this entire time, out of this 44 units, CPU is idle only for 2 units. Therefore percentage of time it is idle is 2 by 44 into 100. Okay. So don't include this. The reason is this could have been included in some other schedule. So by this time CPU is free, then CPU could be allocated to some other process, right? We are not holding it. In case if you have one more burst time here, then maybe you could include it. Otherwise it is not required. Okay.